Hi friends, you are welcome. Today we are going to do CRUD operations: create, read, update and delete on DynamoDB table using AWS SDK. Let's get started. We'll have a small recap on how important when it comes to design DynamoDB table in order to benefit from the performance provided by the AWS on DynamoDB. All you need to do, you need to make sure to have well distributed partition key. Well distributed partition key is very important to avoid hot partition. I will explain what hot partition later videos. And second thing, you need to make sure to identify the local secondary indexes, because you will not be able to do the local secondary indexes once table is created. As DynamoDB is schemaless, you can pass any attributes at any time. All you need to do to identify your primary key. The primary key is a well distributed partition key and sort key. Along with it, you have to identify your local secondary indexes if you want some other column to be searched to be used as a sort key. And that's it. You are good to go with table creation. In today's video, we'll be using small nodejs application which will use AWS SDK for JavaScript version 3, which is compliant with ECMAScript 6. Alright, enough talking, let's get started. So let's start working on our exercise. We will be doing CRUD operations on AWS DynamoDB. We'll be using AWS SDK version 3 in this case. The agenda for today's lecture is CRUD on DynamoDB. We'll be doing the table operations, item level write operations, item level read operations. Have a look at our table. We'll be using this table, TBL exam result. We'll have 4 columns: student ID, subject ID, marks and result. So the student ID will play the role of partition key. It's a well distributed partition key. If you can see, student IDs are repeated. And the subject ID is a sort key. So student ID and sort key should be unique in this case. We have a column marks to store the marks, attribute result where we store the student result pass or fail. I will make this one as a LSI, result along with the student ID. Student ID and result will form a LSI in this case. Let us look into the table operations. We will be creating a table, updating a table, list a table, describe table and delete the table. Write operations will create a new item, update that item, delete that item. Also, we'll do the batch write. When it comes to batch writing, how to do the batch writing, we will do this in this exercise. Read operations will scan items and query items. If you want to follow along with me, the prerequisite for this hands-on exercise, you should have AWS CLI setup done on your workstation. I have earlier published a video how to set up AWS CLI on Windows machine. I'll be pasting the link in the description. The second requirement, you need to have nodejs be installed. And third one, the text editor. For this case, I'll be using Visual Studio Code. So let us create our project. There is a folder, a main folder. From the main folder, I have a git bash utility. Click git bash. We'll create a new directory, mkdir dynamo CRUD ops. This is my project folder. cd dynamo CRUD ops code dot, so that this will be opened in the VS Code. With it, my project has been opened in the VS Code. Okay, it's a brand new folder, nothing inside. I'm opening the terminal. I'm going to write some command, npm init -y. With that, I'll be gifted with package.json file. From here, I can add my packages. From the terminal, npm install @AWS SDK / client DynamoDB -- save. Hit enter so that this package will get installed and will be added to our package.json. So the main dependency has been added. If you look at the package.json, if you look at this, the dependency AWS SDK client DynamoDB version 3 has been successfully installed and added to our package. Now let's create a file to do table operations. In the top menu, click icon to create new file. My table ops.js. Here we need to import the required classes. Let's do that. Import DynamoDB client from this one. Let us instantiate this class const client new DynamoDB client. We need to, there is an argument, we need to provide our current region. The current region, for my case, I'll be using US East 1, right? Now let us go and create a new table. So let create table is a function, is a async function. That is, now we need to have a command object, command class. Let us go and import that command class, which is create table command. Create table command. Let command equal to new create table command. This create table command takes some argument, some parameters. First of all, we need to provide the table name. Our case, the table name is TBL exam result. All right, done. After the table name, we need to have the attribute definitions. To speed up development, I'm pasting the attribute definitions. We'll have 3 attribute definitions: student ID, which is a type of number, and subject ID. Again, this will be also the number. The result will be string. So the attribute name, attribute type. Okay. And now we need to create key. We need to provide the key schema. After the comma, the third component is key schema. Here I am providing the key schema after the attribute definitions. Our case, the key schema is student ID and subject ID. The student ID is a partition key. That's why it is a hash type. And the subject ID is a sort key. It's a type of range type. Now, after this, I will be providing the local secondary index. Local secondary index is a combination of another sort key, which is a result. Another attribute result will play as a sort key. It will work with the existing partition key, which is the student ID. The existing student ID is a hash and result is a range. Okay. So the name of the index is students by result. So this is the local secondary index. This must be created during the table creation time only. Projection, the projection type all. So we need to project all the attributes in this case. After that, finally, we need to provide the provisioned throughputs. I am pasting the provisioned throughputs. The provisioned throughputs for this demo, we can specify the read capacity unit 1, write capacity unit 1. So the command, create table command, having the attributes like components like table name, attribute definitions, having set of attributes, and key schema has mentioned, student ID and subject ID, local secondary indexes also mentioned. It is combination of student ID and result. We also mentioned the provisioned throughput. Okay. Now let response equal to client dot send command. We need to await because this is a async call. That's it. So this is a command. This command must be sent to the DynamoDB client and will wait for the response. Let us console.log the response. Okay. So this is a cute create table method. Now I'm going to call this create table method. Create table method. Save. Now execute it by calling node my table ops. Hit enter. Now you see table status is creating. Our table is being created right now. Okay, clear. Let us check AWS DynamoDB list tables from the CLI to see whether the table is being created or not. Yes, excellent. Now let us head to the AWS management console and go to the DynamoDB service and browse the list of tables. In our case, we have only one table, TBL exam result. Now we'll go through the configuration. TBL exam result, the status is active now. And if you look at the read capacity unit and write capacity unit, both are configured 1:1. Excellent. This is the value we provided from the code, our SDK, okay, our nodejs application. The partition key is student ID, sort key is subject ID. Fine. Now just click TBL exam result table and go to the general configuration. Things are looking same. Okay. Item summary. Currently there is no item. Come to the indexes. If you remember, we created one LSI, local secondary index. The index is student by result. To reading the students by result, it is the LSI which is sharing the partition, same partition key student ID with the new attribute result. Okay, excellent. So we have done with create table. Now let us do update table. Okay, for this we need to refer the update table command. Create update table command. Okay, we need to refer update table command from the package. Now let us create a variable. Let update table is a function, again async function, that is, let us instantiate the update command, let command equal to new update table command, which will take some parameters which I'm going to paste. Here we have to specify the table name, table exam result. As a part of the update, we will be updating the provisioned throughputs. We want to change the provisioned throughput read capacity units and write capacity units from 1 to 2. So here I put 2 to. Okay. So only we are going to change the provisioned throughput. Now let us capture the response equal to await client dot send this command. Let us capture the output console.log response. Now we'll call this update table function, update table. Save, again come and execute it. Let us clear the screen. Node my table ops. Excellent. Now the table status is currently updating. Okay. And now let us head to the management console and to see the verify the changes. I'm going to the DynamoDB table, refreshing it. Now, if you notice, the provisioned throughput is changed to 2 from 1. Okay. Excellent. Now let us explore other APIs. Next, we will explore list table. Okay. For this, we need list tables command. Okay. List tables command. Here we have to list all the tables from the DynamoDB. Okay. List tables is a function, async function. That is, let us instantiate the list tables command. Command equal to new list tables command, where we don't have to provide anything. We can simply leave it. Let response await DynamoDB client dot send this command. All right, send command. Let us capture the output. Console dot log response. Okay. Now let us execute the tables. Make sure the changes are. Let us clear the terminal and execute node my table ops. Excellent. You get the output. Our tables are listed. Table name is TBL exam result. Also, we'll go and describe this table. Okay. For this describe table, in order to use the describe table command as is required. Describe table command. Let us hide these tables. Okay. Let us create a new method. Let describe table is a async method, which is let us set up let us instantiate the command equal to new describe table command, where we have to provide the table. Okay. Table name tbl exam result. Fair enough. Let us capture the output response. I'll send it to the client dot send command console dot log response. Now we'll call this one describe table. We need to we can do one thing to make it beautiful. JSON dot stringify. We'll send response
Okay. Save, clear the terminal, and go again to execute table ops. Excellent. If you notice the output, this describe table command give us the option to view all the table attributes, attribute definitions, and key schema, and local secondary indexes, and provisioned reports. So we'll get the complete picture by this API call. Now we will do the last table operation, which is a delete table. For this, we will use a refer a class delete table command. Okay, delete table command. Let delete table. It's a async function. Let us instantiate the command equal to new delete table command. Here we have to specify the table name. You can copy the table name from here. Table name. Okay. We copied the table name. Also, we can copy the same content. We can copy the same code here. We will be sending the delete command instance to the. We'll be sending the delete command object to the client. Now let us call this delete table. All right. Now save and execute node my table ops deleting. Excellent. Now let us explore. Let us log into the console to see whether table is deleted or not. If you see, if you refresh, your table is no more. Okay, that's it. Now, so far we have explored all the table operations. Now, next step is we'll go for the item level operations. Okay, so in order to do the item level write or read operations, we want the table to be back. If you remember, we deleted this table, so we'll call the create table again. Create table. Okay, so I'm removing the delete table. Let's uncomment the create table. Okay, now let's make sure to save changes and node my table ops. Let's run it on this terminal. Now the table is being created again. Okay, now once the table is ready, we'll start working on the table level write operations. To perform DynamoDB item level read and write operations, we need another library which is document client. So in order to use document client, we need to get it installed. So let's do that. npm install @AWS SDK / lib hyphen DynamoDB save. This will install the library required for this operation. Document client will get installed. Done. If you go to the package.json, you will find another library get installed, lib DynamoDB. Okay, so let's do our write operation. Okay, in the root folder, click here to create a new file. We'll call it like my write ops.js. Okay, now we need to refer these libraries. So import we need DynamoDB client. From this client DynamoDB, also we need to import the DynamoDB document client from this library. Okay, let us instantiate the client. Let a const client new DynamoDB client. Let us specify the region, the default region, my case US East 1. Now let us instantiate the document client, doc client filter DynamoDB client dot from DynamoDB document client. DynamoDB document client from there we have to pass the client. That's it. Okay. Now let's create a variable, create item. Let's create item, single item. Okay, let's create equal is a function. Yes, is a function. To add item, we need a put command class. We need to refer the put command from the lib DynamoDB. We have to refer put command. Okay, let's create instance. Let's instantiate put command. Let command new put command. Here we have to specify the configurations. Inside the put command argument, I am pasting the required values. Here I have to mention the table name. TBL exam result is our case. Then we have item. Item is object where we will pass sample values. Our case the student ID and subject ID and mark and result. Okay. Now let us specify the response equal to doc client dot send. We need to send this command. This is async method. We need to wait it. Okay. Let's console the output. Console dot log response. Okay. Make sure to save changes and call this function. Save changes. Now we'll run this node my right of it enter in the terminal. Now we get a success response 200, which means this item is being created already. Just confirm. Let's go to the table, select the table, and there is option to explore table items. Scroll down. Let's refresh. You will find one item. Okay, 2154, the same item which we inserted now. Okay, so we inserted one item. Now we'll do update. We'll update the same item. Okay, let us comment this create item. In order to update item, we have to refer another class which is update command. Okay, update command for the from the document client package. We need to refer other class update command. Okay, so let's create update item is the async function that is. Let us instantiate that command. Let command equal to new update command. Okay, update command. We have to specify the update configuration. Now let's copy the. I'm copying the table name. I have to mention the table name inside the update command as argument. which is the TBL exam result. The key I have to mention, the primary key, the student ID, the same student ID, subject ID is 1. Okay. If you go to the console, you will find the student ID 2154 and the subject ID 1. Earlier I passed mark 25, which is failed. This time I'm going to update the result is pass, mark is 80. In order to do that, I had to mention the update expression. Update expression set hashtag re result equal to this result. Okay. So this is update expression. These update expression names. If hashtag or result means is a result attribute name. Hash mark means MRK means mark. Okay, this is a name part and this is a value part. Expression attribute values. Result this segment I am passing the value which is pass and mark 80. Okay, fair enough. Okay, this is a command here. Now let us receive the response from await talk client dot send command. Okay, let us log it console dot log response. Will log this response and this is update item. Okay, let's call this update item function. Make sure to save changes. Let's clean up the terminal. Let's call my write ops. Okay, again we get the success code 200. That means item is updated already. Let's verify the changes by refreshing it. If you notice, the same primary key mark 80 and result is updated with pass. Excellent. Okay, then now we'll do the deletion part. So to delete, we need to refer delete command from the document client. Delete command. Let us comment this update item. Let's create delete item. Item is the async function again. Let's instantiate command new delete command. Okay, we need to provide the primary key, which I'm copying here, the table name and primary key. We need to specify the primary key, which is a student ID, 2154, same primary key, same subject ID. Okay, done. Let receive the response equal to await doc client dot send command. Let's log it console dot log response. Okay, let's call this delete item. Delete item. Save changes. Clean up the terminal. Node my write ops. Congratulations, we again received success code 200, which means our item gets deleted. If you refresh, there is no item. Okay, good. Now let us explore batch write command. Typically, we send large payload for the bulk insertion. So in order to the batch write, we have to refer another class, which is batch write command. Okay, batch write command. Let me comment this item, delete item. Okay, let batch write is a function, async function that is. Let me copy the code. So here I have a set of items like exam info. I have different, different partition keys. I mean primary keys. subject ID, different, set of items. For this case, I have like 3 items. Okay, let's consider this a bulk update. Okay, batch writing. So here I refer, I instantiate the batch write command. Here I have to provide the request items. Okay, this is very important. Request items. Here I have to mention the table name. Table name directly it will get inserted. Every item will be mapped and create like a put request. Okay. Now let's call this one. Let response await dot client dot send this command. Okay. Let us log this response console.log response. A batch. This is batch, right? That's right. Save changes, clean up the terminal, and node my right off. Congrats again. We get the success code 200. Let's go to the terminal. Let's go to the console and refresh. We find 3 items. Okay. The batch update, batch writing is successful. Okay. Now let's do some read operations. For that, let me create a new file, my read ops.js. In this file, let us do the same. We'll have imports. We need to import the DynamoDB client. We also require document client. DynamoDB document client. Let us instantiate client new DynamoDB client. Inside, we need to specify the region. US East 1. Fine. Now let us instantiate the doc client. DynamoDB document client from, we need to pass the client inside. Fair enough. Here we have to do 2 things, 2 operations. One is scanning, the other one is query. Okay, we'll explore both options here. Now let us work on the scan item. Let scan items is a function, async function, that is, now we need to import the scan command. Scan command in order to do the scan items. So we need to let us instantiate the scan command. Okay, here we need to provide the params. Okay. Okay, I copied this scan params like filter expression. Scanning is an expensive operation in DynamoDB. Visit every partition and fetch the item. So in order to do the scan operation, we don't have to provide the primary key. Okay, we don't have to provide the primary key, partition key or sort key. Only we can simply provide the expression. So we can say the filter expression is result. Okay, the expression values, we want only the passing students, and the names are result. Okay, the result is a result. We are passing the value pass. Okay, projection expression, we want, this is the projection expression, student ID mark. Okay, table name TBL exam result. This mention we have to mention. Projection expression, we only require these two fields, attributes. Okay. Now we define this scan command and we have instantiate this command. Now let us receive the response. Let response await client send command. Okay. Let us log the response console.log response. Okay. Scan items. Let us call this method scan items. Save all. Now let us execute this one. Node my read ops. Now, if you notice, we get the response from DynamoDB. We got the success response 200, and you will find 4 items. Student, these 4, we found 4 items with passing, all passing marks. Okay, this is the result of the scan operation. Now we'll do the query operation. Okay, for querying we have to provide the partition key. We have to provide the primary key. Okay, we are done with scan operation. Now we'll do the query operation. So let me minimize this and comment the scan items. In order to do the query operation, we need to import query command. Okay, query command from the document DB, from the DynamoDB document client. We need to refer the query command. Okay, now let us create a variable query command query items. The query items is a function, async function that is. Now we need to instantiate the query command equal to new query command. Okay. Here we need to provide the query command params. Okay. Inside the query command, I'm pasting the arguments. Here I mentioned the table name, civil exam result, and the key condition expression. The key condition expression, the student ID. The student ID is the student ID value. This is the name and this is a value. Okay. Here you will find the expression attribute name like student ID. Hash student ID is a student ID attribute. Hash result is a result attribute. Result I'm mentioning as the projection expression. Okay. So the primary partition key I have where I have mentioned here expression attribute values is student ID equal to 12458, which is exactly the partition ID. Okay. So I'm passing the partition ID to fetch all the related items. Okay. So this is the most efficient querying operation. This is what we are doing now. This consistent read is read. I don't want strict consistent. Eventual consistency is enough. Okay. Now let me receive as a response. Let response equal to await client dot send command. Okay. Let us log to the console dot log response. Okay. This is query items. Now let me call this query items function. Make sure to save everything. Let us clean up. Okay, now I'm going to execute this node my read ops. Excellent. I get all the items result matching with my student ID 12458. Okay, I get the result to fail, result to pass, result pass with various marks for particular student. Okay, which is a partition key of my case. Okay. So with this, we are concluding our session. So far, we explored the table operations, item level write operations, and item level read operations. I hope you enjoyed this video. I will see you next time with another interesting AWS topic. Thank you.